What are you? Can you see anything that side?
No, sir.
Oh, okay. Let me quickly try to do so. Hi, Nicole. Is there anything now that you are seeing?
Yes, sir.
Okay, then let me do this. Mm, you said Euclidean. Hi, Nicole. Is there anything now that you are seeing?
Yes,
How
sir.
to I on the textbook. Let this. You said Euclidean. Hi, Nicole. Is there anything now that you are seeing?
Yes.
Something is disturbing me here. Let What's happening? This. Can you see the textbook that side?
Yes, sir.
All right, thank you. But I don't know what's happening because I keep on hearing this sound here. Right. Let me just close this. Okay. Uh, just please hang there with me. Okay. Yeah. Boom, 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 boom. So you want us to start with where Euclidean geometry, the grade 12 one starts, or maybe is there any part that you specific want assistance with? Or you want us to cover almost everything there?
Almost everything, sir.
Oh, okay, it's fine, it's fine. Let's go. Mm, quickly go there. Okay, here it is. So here is what the proportionality theorem looks like. We have this triangle ABC, right? And
Yes,
then
sir.
in this triangle, we are given this line PQ, and we are given that PQ is parallel to BC. Then now I'm saying to you, if you are given this triangle, then you are told that PQ is parallel to BC, then proportionality theorem applies. Does this make sense?
Yes, sir.
Okay, thank you. Then now, if maybe I come to you, I say there is this triangle A, B, C, and then I give you the line D, E. And then with this triangle that I've just drawn here, you cannot say proportionality theorem applies. Why? Because you are not convinced that this line is parallel to this other one. Unless now I give you more information that DE is parallel to BC, then now you can conclude by saying a proportionality theorem applies. Does this make sense?
Yes, sir.
Okay, then thank you. Let's quickly now go to the application of this theorem. Now let's say we have this AP here. When you take the ratio of this AP over PB, that should be equal to the ratio of the other side, AQ over QC. Do you get this?
Yes, sir.
Okay, thank you. Same applies now if you play around your sides. You take the whole side AB over there, maybe this other side AP should be equal to the ratio of other side. But if you started with the whole side, even on the other side, you should start with the whole side of the other part AQ. Does this make sense?
Yes, sir.
Okay, then thank you. Then and so on, you will play around your size and ratio when you apply that proportionality theorem. But remember, as I always emphasize this, that in Euclidean geometry, you put the statement and then you accompany that statement with a reasoning. So if this is your statement that AP over PB is equal to AQ over QC, then why are you saying that? Because it's the line parallel to the side of a triangle. But this is the reason I love the most proportionality theorem. Why? Because PQ is parallel to BC. Then you are done. You put the statement, you put the reasoning. That's what matters. Does it make sense?
So can you please explain this reason here, the line parallel to side of the triangle?
This one.
Yes, sir.
Or you can either yes use this one. It's up to you whether you can use this one or this reasoning prop. Oceanal theorem PQ is parallel to BC. Or you can still use this one that they mean it's a line parallel to the other side of this existing triangle. I don't know if this makes sense.
Oh, yes, sir.
Okay, then, thank you. Now let's go to the real application of this problem. Let's go. Let's go. Let's go. Let's go. Oh, we've got a corollary here, the midpoint theorem. This midpoint is saying a line thrown through the midpoint of one side of a triangle. And then you are given, okay, for instance, let's say this is our triangle right here. And then now there is a line drawn through the midpoint of this side. Meaning if this side it was 4 centimeters, I'm going to put it on exactly on 2 centimeters such that it is on the midpoint of this side. And then you are given that this line is parallel to that other one. Then it bisects this other side. Do you still remember what does the term bisect mean?
No, sir.
A word bisect means it cuts the other part into two equal parts. So here, if they say this line here bisects that line, it means this line cuts this other line into two equal halves. Does it make sense?
Yes, sir.
Okay, thank you. Then let's go to the other part. Okay. Now we've got these examples here. Example one, they are saying in the following sketch, PQ is parallel to BC. PQ here is parallel to BC, and then we are given AP as 10. Okay, you are given PB as 6. We are given AQ as 15 and QC as X. Okay, so what you are going to do in this part, so you are going to take the side AP all over the side PQ, that will be equal to AQ all over QC, all over QC. So this is what we write, AP over PB is equal to AQ over QC. Then this is the statement. Now provide the reasoning behind that statement that, okay, this is a proportionality theorem. Why? Because PQ is parallel to BC. Then now from here, you substitute. What is AP? AP is 10. What is PB? PB is 6 is equal to AQ is 15 over QC. QC is the one that we are looking for now. It's X. Therefore, now you work out your maths, you cross multiply. 10 times that X is going to give you 10X is equal to 15 times 6. I think it's 6 times 15 is 90. And then 90, therefore your X will simply be 90 divided by 10 is 9, 9 units. Then you are done just like that. Does this make sense?
Yes, sir.
Are you sure?
Yes, sir.
Oh, okay, thank you. Then now let's go to the question, and then now I'm going to ask you those questions on how we maybe can tackle those questions. Okay, let me quickly remove this mess here. Now, mm, okay, actually, you can just work around this example. So we've got this number B in this example. They are saying in the following sketch, given this part that ST is parallel to PQ. This is a very important information. You need to note this. Okay, PS is 9 centimeters. PS is 9 centimeters. SR is 27 centimeters. QR is 24 centimeters. Now, what are we looking for? We are looking for TR. So, do you have any idea of how we can calculate the length of TR?
You say, I think that you say P R over SR is equal to QR
So
TR.
You are saying PR
Yes, sir. Over
over
SR
SR
is equal to QR over TR.
QR over TR. Okay.
Then we say PR, which is 36 over 27, is equal to 24 over TR.
Okay, yes. And then now you play around your maths cross multiply to solve for the value of TR, right?
Yes, sir.
Yes. But you left out something in this step here. What do you think that is?
The reason.
Yes. So what the reason will be?
Proportionality theorem.
Oh, yes, prop theorem. Then you state your parallel lines that PQ is parallel to ST.
Yes, sir.
Yes. Then now, okay, you understand that. Now let's come to these ratios and fractions. Because so far we did those fractions that if or if now this is what is being said by this. If you are given a ratio AB over BC like this, you can write, okay, let's say you're given this as A over B. Now you can write this in terms of a ratio that's now AB is to BC. That is the same as A is to B. Does this part make sense?
So is the first one given always the numerator?
Yes,
Okay, sir.
yes. So you get it, nah?
Yes, sir.
All right, thank you. Then here the problem that involving the ratio and the length. If you are given, this is very, very important. If you are given a ratio like this, if that AB is to BC is equal to M is to N. With this case, let's that AB, you introduce the variable X for that part M. You also introduce the same variable X for N. Does this make sense?
Oh, sir.
Okay, let me try to explain this. If, for example, I'm saying maybe let's say we are given that A AB just like this. AB here is to BC is given as AB, the ratio is M for this part, AB. And then for BC, we can see that it's N, right?
Yes, sir.
Then always for these ratios introduce a variable, any variable, A, it can be B, It can be C, it can be X, it can be Y. But if you gave this a variable A, then also this one, because it's the same line, give it a variable A. You now get it.
Yes.
Yes, this information will help you a lot, big time. So now we'll see how to apply this on a problem. Now let's continue to the next part. Okay, we have this part here. So here in the sketch alongside AB is to BC. We are given that as 7 is to 3. This is the ratio. For AB, it's only the ratio, it's not the length. Is what AB is 7, give it the variable A. BC 3, give it the variable 3A. Okay, now you are cool with this. Are we still together?
Yes, sir.
Okay, yes. Now, what do you think we are going to do now to solve for the length of BC?
I think we say 7 7/3 is equals to 21/PC.
You are saying
7/3
7/3
is equal to 21/PC.
is equal to 21 over BC. Okay,
Then we cross multiply.
then we cross multiply that. Okay, 7 BC is equal to what? 30, is it 63?
Yes,
63
sir.
times 21, I get 63. Therefore, BC is now equal to 63 divided by 7. It gives me 9. It gives me 9. So, wait, what was going to be the value of what was going to be 3? Okay, fine. That's 100% correct. Then now let's go for B. B is requiring us to calculate. Okay, we are saying the length for this is 9. Now we are required to calculate the length of or the ratio AG over GD. Now, how do you think we are going to find the ratio for that?
I don't know, sir.
Okay. Now you play around your proportionality theorem. This is what you will do. Do you agree if I say now AB over BC is equal to AG over GD? Do you agree to this? Then my reason is a proportionality theorem. Then BG is parallel to CD.
Yes, sir.
Okay. Then what was the ratio for AB over BC?
7/3.
Over 3. Then this will also be 7 over 3, just like that. Do you now get it?
Yes, sir.
7b, you can give it the variable over 3b. Okay. Then the last one, we are required to find the length of FE. Now, how do you think we are going to find the length of FE?
Do we use the ratio for AG over GD?
So, how maybe?
AD over GD
So, so
is
AD over GD.
equal to AE over
Okay,
FE.
over FE. Okay, and then now you substitute. You substitute, right?
Yes, sir.
Then what is AD? Is 10B, right? 10B all over This is going to be 3b is equal to AE is 20 over FE. And then this B cancels out. Then now you cross multiply. That's 10 FE gives us 60. Therefore, FE is going to be that 60 divided by 3. Divided by 3. Oh, by 10. Then we get 6. Do you agree?
Yes, sir.
Okay, then that's going to be your answer. So it seems like you are a little bit comfortable with these ones. Let me go find some challenging problems. Hmm. Okay, are you cool? Can you answer this question? But I believe you can.
Yes, sir.
Oh, okay. Let me go find some maybe challenging questions. Boom, boom, maybe like can start maybe. Uh, okay, here, actually, here. So this is what we did with the last question. I think when we were together with the whole class of grade 12. So with the previous part that we did, we were working out around a proportionality theorem whereby we were given parallel lines. So now with this part, this is where we are now required to prove that lines are parallel, which is now the reverse of that proportionality theorem. So if you do the reverse of something in maths here, that's the converse. So that's the converse of that other thing. So now here, this is the converse of that theorem one. Do you remember theorem one is that one whereby we were given the parallel lines and then we said the ratios are equal. So now we are
Yes,
doing it in reverse order. If now we are given that the ratios are equal, we can conclude by saying the lines are parallel. Then the reason says that the line divides two sides of a triangle in proportion. Does it make sense?
yes, sir.
Okay, thank you. Then now we have got this example here whereby we are given AP as 12 units here. We are given PB as 8 units here. We are given AQ as 15. We are given QC as 10. Okay, now what you will do, you will want the ratio for this side first, okay? AP over PB, which is this one, 12 over 8, gives us 2 over 3. Then we go to the other side. We want the ratio for that side. AQ over QC. AQ over QC. Then 15 over 10 gives us 2 over 3. Therefore, now, since these ratios are equal, it gives us the confidence for us now to say that this line is parallel to that because the ratios are equal. Does it make sense?
Yes, sir.
Okay, thank you. Then let's go to this other one now. This one in the sketch alongside we're given that AB is 9 meters. Okay, BC is 6 meters. And then AD. So this one you can write this in this way because AD is equal to 3 over 5 AE. So you can divide by AE on both sides. AD over AE is equal to 3 over 5. So you understand this part.
Yes, sir.
Okay. And then now we are required to prove that this line is parallel to this one. So in order for us to prove that these lines are parallel, we need to show that the ratio of this over this is equal to this over this. How can we do that? We first need to find the ratio of this line AF. How can we do that? We can see that in triangle ACF, proportionality theorem is applicable because BG is already parallel to CF. So we can simply say uh, A AB over BC is equal to AG over GF. What was AB was 9 over BC. BC was 6. Therefore, 3 goes 3 times. Then it gives me 3 over 2. Okay. We have 3 over 2 for this ratio. And then what else? AD here, we are given that AD is 3. Okay, is 3. And AE as the whole, we are given that AE is 5, meaning we can find that DE is 5 minus that 3, which is 2. Now let's try to find AD over DE. AD over DE gives me a 3 over 2 as well. So now, since AD over DE is equal to AB over BC, you can now conclude that GD is parallel to FE, then you are done. Does it make sense now?
So the AF, can you please go back there, sir?
Where maybe?
The AF,
AF.
yes, sir.
Uh, oh no, this is AE. Excuse my bad handwriting.
No, sir, this one AF weighs 3 over 2.
Uh, Here,
Yes, sir.
you want me to re-explain this, eh?
Yes, sir.
Okay, okay. I'm saying now here AB over BC, which is AB over BC is equal to AG over GF. Do you agree?
Yes, sir.
Okay, yes. Then what was AB? It was 9 here. What was BC? It was 6. Then you simplify this, it gave me 3 over 2. Are you
Yes,
now
sir.
here? Does it now make sense?
Yes, sir.
Okay, thank you. Then let's go. Okay, same applies with this example 7. You are just going to play around your proportionality theorem until you prove whatever you are required to prove. So now let's quickly go to maybe this part for the multiple ratio on a line. Now to play around those ratios. Now here, we are given the ratio for AB is to BC. AB, so I said what you need to do is this. If you are given the ratio, introduce the variable. AB is 3, let it be 3A. Then BC is 2, give it the variable as well. 2A, fine. Then now, BC is this one, you are given 6, give it another variable, 6B. Then 6CD is 5. 5B. Okay. Now go to the question. What does it want? Oh, it's A, B, C, D. So you can write that as a fraction. The first one is a numerator. AB over CD. Fine. What is AB? It's 3A over CD. Here is CD is what? It's 5B. 5B, like this. But now, one can be curious. So now, what are we going to do? We are here. The other one is in terms of A. The other one is in terms of B. Now, what can we do here in order for us to get that final ratio? Okay, here to this part, we can see that BC is equal to BC. Why? Because 2A is equal to 2B. We're going to say BC is equal to BC. What is the BC on top there is 2A. What is BC down there is 6B. So you can just make A subject of the formula 2, 2. Then A gives me 3B. Aha. Now, wherever you see A there, you plug 3B. Now we are going to have 3 times 3B all over 5B. This B cancel out with this B. You are left with 9 over 5. Therefore, that ratio will be 9 into 5. Then you are done. Does this make sense?
Yes, sir.
Are you sure?
Yes, sir.
Okay. Then let's quickly move to the other one. And then it's to 5. Fine. We have this one. Now tell me what we can do in order for us to achieve this problem.
So you can say QS
What PS?
QS over QR, I think, sir.
You are saying QS over QR. You are the one who are saying. You are saying QS over QR.
Yes, sir.
Okay.
Is equal to 2 over 5.
QS over QR you are saying is 2 over 5. Okay.
Then from there, sir, I'm not sure, sir.
Okay. Now, this is a wrong approach that you used. So this is what you need to do always when you get to these problems that gave you a ratio. So you are given a ratio here, here, what's happening? So you are given a ratio here, here, that PQ is 2, is 2. Then give it a variable A. You're also given QS there. QS is 3. Give it a variable A. 5. You're given another ratio here. QR, it's 5. 5B. And then RS is 3. RS is 3B. Does this part make sense?
Yes, sir.
Okay, thank you. Then go to the question on look what you are required to find. QR, QR is this 5B, okay? Is this 5B here? This 5B here all over PQ. PQ is this part here, 2A, 2A. Now you need to find the relationship between B and A so that you can just make the ratio of one variable. So how can we find the ratio of that? We can see that here QS is equal to QS. Why is that the case? Because first QS is 3A, excuse me, the other QS is 5 plus 3, it's 8B, 8B. Then you divide by 3, you divide by 3, you get A is equal to 8 over 3B. And then now just come here and have 5B all over 2 times 8 over 3B. Then the B cancel out with the B, you are going to be left with 5 over 1 divided by 16 over 3. This gives me 15 over 16. Then you are done. Does it now make sense?
Yes, sir.
Are you sure?
So how do you know that the relationship between the QS and the other QS, why are they different values?
Okay, look. That is why these scribbles are important, because what we noticed here is that we were given this QS here as 3, right? Did you see
Yes,
that?
sir.
Okay,
Yes, sir.
yes. That QS here is 3. And then we wrote that 3 here, and then we gave it a variable A here. You agree to that, right?
Yes, sir.
Fine. We were given QR here, right? And then QR we started here, we moved from Q up to R, that was 5, and then we gave it a variable B, right?
Yes, sir.
And then we were given RS here as well, R from here to S there. So that was 3B. Now, do you agree if I say for this part, QS there will be this 5B plus that B? Do you agree to that?
Yes, sir.
Therefore, because this is QS and this as well is QS, those lines are equal, right?
Yes, sir.
Therefore, you are allowed to say 3A is equal to 5B plus 3B, which is 8B is equal to 3B. That is what I did here.
Okay, sir. Thank you, sir.
Does it now make sense?
Yes, sir.
Are you sure?
Yes, sir.
All right, thank you. Then let's go to the other one. Maybe let's try to find a complicated one. Oh, maybe this one here. So now tell me what we maybe can do in order for us to find this ratio here.
So we first put in the data we were given
Okay,
in that
then what are we given?
they tell us that AB
A
is
A
three
A B.
is 3A,
Okay.
then BC is
Oh,
2A,
okay. That is 2A. Okay.
and AC is
Okay.
10B,
This is 10B. Okay.
then CD is
CD
3B.
is 3B. Okay. And then now,
Then we find the common relationship between AD and AC.
okay, how maybe?
We say AB is equals to AB.
You are saying AB.
Also say AC
Okay, you are saying AC
is equals to AC.
is equal to AC. Okay.
Then we say 3A plus 2A is equal to 10B.
So you are saying 5A is equal to 10B.
Then we say 5A is equal to 10B.
Okay.
Then we divide the the 10, we divide both sides by 5,
Mm-hmm.
which gives us A is equals to 5B.
5B.
2B, sorry, sir, 2B.
Yes. 2B. Okay.
Then AB is B. Then I think we say here by AB, we say 3A,
You're saying AB is 3A. Okay.
which is equal to 3 times 2B.
So that is going to give us 3 times 2B. Okay. 6B.
Then to find BD,
Mm-hmm.
I don't know what we do here.
Okay, so BD, we can see that it's this portion, right? It's this portion here. It's not too bad. It's this is BD, right?
Yes, sir.
And we have AD, right? As
Yes,
10. as that's 10b plus 3b. Then we can just say this 13b minus this part here to be left with bd. Can you see that?
Oh, yes, sir.
Sorry?
Yes, sir.
Okay, yes. Now bd is equal to ad minus ab. ab. Then what is ad is 10 plus 3 is 13b minus AB is 3A and 3A we said is 6B. We said it's 6B. Then now this is 13 minus 6 gives me, is it 7?
Yes, sir.
Okay, then it gives me 7B. Therefore, AB over BD. What is AB? AB is this is, oh man, what is this? Is this BD? Okay, we want BD, AB over BD. This is going to be 7B. This is going to be 6B. This cancel out. Therefore, the ratio is 6 is to 7. Then you are done. Does it now make sense?
Yes, sir.
Are you sure?
Yes, sir.
Okay, now let's do the last one so that we can use the ratios to approach the problems. And now, how do you think we can do this number B here?
We put our info, the data given.
Okay, can I please quickly just erase this part here? I'll be done soon. Okay, I think. Okay, I'm done. Almost there. Almost there. Almost there. Okay, okay, I'm done. So you were saying,
We plot our data.
so you plug our data. What is the data that we are given?
KL is 3A.
So KL is 3A. Okay.
LN is 13A.
Okay.
KM is 5B.
Okay.
Then NN is 3B.
Aha. Aha. You are cooking now, and I'm impressed. I'm glad. I'm glad. Yeah. And then,
You say, you say, I think it's K.
aha.
I'm still looking. Sir.
Oh, okay, okay. Let me just wait for that.
So I don't know if I use the whole line, like KN is equals to KN.
Oh, yes, you're not wrong. You're not wrong. Now you are thinking like a mathematician. I'm impressed. You're saying Kn is equal to Kn, right?
Yes, sir.
Okay.
Which is 3A plus 18A is equal to 5B plus 3B.
Okay.
Then it's 16A is equals to 8B.
Sorry?
16A is equals to 8B, and then we divide both sides
Oh,
by
yes, we do. By what?
8.
By 8. Okay. 8. 8. Now our B is going to be 2A, right?
Yes, sir.
Okay.
Then we
Okay.
say L LM
LN. KL
LM.
or LM. You are saying LM. Okay.
I think it's LM is equal to KM minus KL.
So LM, can you see that is this part, right?
Yes, sir.
So you are saying it's what is K?
KM.
You are saying that is KM minus KL, right?
Yes, sir.
Okay, okay, I love it.
Then we say 5B
Okay, KM is 5B minus, okay?
minus 3A, which is 3 times
No,
2A.
no. Look at this. Can you see that? Do you agree to that?
Oh, yes, sir.
Okay, yes. And then now this is our LM. And then what do we do now next?
To find KL, I
We
think we say,
find KL. Okay. It's K.
K KN
We are saying K.
minus.
But but look at this. KL just is 3A.
Okay, so sir.
Then now KL over LM is equal to 3A over 7A. Therefore, you are left with 3 over 7.
Yes,
Then
sir.
does it make sense?
Yes, sir.
Are you sure?
Yes, sir.
Okay, then now let's let's just maybe try to use whatever information that you have learned on this problem. Uh, this is the problem. No, this one. This one. In the sketch alongside, now it's no longer that just a line. It's a triangle whereby we will be playing around proportionality theorem, whatever, to cook something. But okay, let's look at the information that we are given. AD is to DB. AD is to DB. Is that one is 7? Maybe A is to B. DB is 4. Do you agree if I say A D over D B is equal to A E over E F? They are both equal to 7 over 4. Prop theorem because DE is parallel to BF.
Yes, sir.
Okay, therefore this AE here will be 7B, and then this EF will be 4B here, right?
Yes, sir.
Nice. Let's go to the other information here, DG, GC. DG, they are saying it's 2, that is DG. 2C maybe. GC is 5C. Then, now do you agree if I say DG over GC is equal to EF over FC? They are both equal to 2 over 5. Prob theorem. Why? Because DE is parallel to GF. You agree?
Yes, sir.
Okay, thank you. Therefore, this one here will be 2D, okay, and then this one will be 5D. Now, I think from here you can cook something to generate this ratio.
So the EF is 2D.
Sorry?
EF is 2D.
Oh, okay, I left some. Okay, yes, thank you, thank you. Okay, yes, thank you. Yes. And then now we are here. We watch that ratio. What do you think?
So I'm still trying to figure it out.
Okay.
I think we say EF is
Oh, you
equal
are
to
saying EF?
EF.
Oh, yes. Oh, now you think like a mathematician. I'm impressed. I love what I'm seeing now. Okay.
Then we say 4B
4B
is equal to 2D.
is equal to 2D.
Then we divide both sides by 2,
You divide both sides by 2. 2, okay.
which gives us 2B.
Okay. Okay. And then now we
Then
go, you can just jump into the question. We want AF over FC. What is AF? AF is this part here. It's 7B plus 4D. That is going to give us 11B all over. FC is 5D, meaning it's going to be 5 times 2B. Therefore, B goes out. We are left with 11 over 10. Then you can write this as a ratio as 11 over, is to 10. Then you're done. Can
yes,
you
sir.
see that?
Yes, sir.
Are you sure?
Yes, sir.
Oh, okay, okay. Thanks, thanks. Let's now move to the next one. Boom, 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 boom. Now we are here. This is the last one. Then we can jump into the trigonometry after this one. Then now we have got this problem. We are given the sketch alongside. We are given the information that AB is parallel to PC, and then PAQAQ ratio, BCCR ratio. Now, how do you think we can approach those questions?
So is it exercise 3?
Yeah.
Is it exercise 3?
Yes, exercise 3.A.
Okay, sir. We plot our data first.
Oh, okay. How maybe?
PA
You
is
are
2A.
saying PA is 2A. Okay.
Then AQ is 5A.
AQ is 5A, okay.
Then BC is 4B.
BC is 4B, okay.
And CR is 9.
9B, right? Okay.
Then I think we can get 2B by saying that 2B over BC is
Yes,
equal to,
using prop theorem, right?
yes,
Therefore, we are going to get this as maybe 5D, and we get this as 2D. 2, 2D, okay? And then
then
now
we say,
what do you think?
I think it's BR is equal to C.
What?
So I'm still looking at it.
Oh, okay, okay, it's fine. Then I will just wait for you. Then we'll shout out after you are done.
I think we say BC is equal to
Okay.
BC,
BC is equal to?
BC,
Okay.
which is 2D is equal to 4B.
2D is equal to 4B. Okay.
Then, which gives us D is equal to 2B.
It gives us D is equal to 2B. Okay.
Then QB is 5 over 5D
Oh,
over
you are pardon?
5D over 9B.
So, so you are saying QB over QB over CR.
Yes, sir.
What is QB is 5D, okay, over CR is this one is 9B, it's 9B, okay,
Then we substitute 2B into D for
times
5.
2B over 9B. Then B goes out, we are left with 10 over 9. Therefore, this ratio for this one is going to be 10 is to 9. Then you are done. But just do me this favor. When maybe in the paper you were writing that this QB over BC is 5 over D, just state that reasoning that it moved there using proportionality theorem because AB is parallel to PC.
Yes, sir.
Yes, then now we can go for number 2. CR over QC. Oh man, this is nice. Still not bad, eh?
Please, sir.
Or is it bad?
No, sir.
Oh yeah, it is not bad at all.
Yeah, I think since we already have QB as 10B,
So you as what? Sorry, you're saying CR. We have what?
for as CR is 9B, and
So you
then
you are saying CR. Yes, I agree that CR is 9B. I agree.
in the previous question, we found that QB is 10B, so we can say for QC it's 10B plus 4B.
So QC. So QC it's 7D. So it can be 14B. Oh, I'm mistaken. Is that correct?
Yes, sir.
Okay, this cancel out. Therefore, this one is 9 is to 14. Then you are down. So do you understand how these ratios work?
Yes, sir.
Yes, now you play around your proportionality theorem using these ratios, and then now once you have those ratios on one side, then you are done. Even these questions, you take them all to one side and then try to work whatever you are being asked to find, and then all will be well. Then you are done afterwards. Is there any questions regarding what we just did so far?
So for number two, do we need any reasoning?
For number two, no. For number two, you don't need any reasoning because everything now is on the same side. Like there's nowhere where you maybe use that proportionality theorem or anything that wants the reasoning. You work only on this side now. So there's no reasoning required.
Yes, sir.
Yes, then you are done. Is that only question that you're having?
Yes, sir.
So can we now move to trigonometry?
Yes, sir.
Okay, what is trigonometry? I don't know what it is. And then this is my content. Trigonometry is in page 141. Then I can just say 141. Okay, but after calculus. Okay, the trigonometry starts here. Yes, so because I don't know maybe how maybe your teachers were moving with you guys with trigonometry. I don't know where to start, but then you will guide me, I hope, where to touch, where to not to touch. So where would you like us to start? Or you want me to cover almost everything just to summarize here and there?
Yes, sir. Almost everything.
Oh, all right. Then if that's the case, maybe what can I do? Okay, then let me. I'm trying to think here what I maybe can do to just cover almost everything within maybe 30 minutes. Dun, 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 dun. Okay, I think let me go to this part. Let me do this. Dun, 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 dun. Let me go to this. Okay, I will use this part. I think I will just use this paper here to just summarize almost everything. Have you ever hear of something like soccer tower?
Yes, sir.
Oh yes, soccer tower. Uh, this thing actually works only with right-angled triangle for trigonometric ratios. So this only works with this part right here. So what do we mean by a right angle triangle? Is that triangle with a right angle here? whereby we have got our angle theta maybe there, and then when we define the sides of this triangle, we are going to have the hypotenuse here. The hypotenuse as the longest side of the right angle triangle and its opposite there, the 90 degrees angle. And then this side here is the opposite of this triangle because it's opposite the angle. And then you have got the adjacent here. Then this is the right angle triangle with an angle. So if you want to work with these sides, hypotenuse, which is this side, and opposite here, you're going to use sine for so here because it's going to be sine theta. Then you're going to take the opposite side all over the hypotenuse, right?
Yes, sir.
And then now if you want to work with this side and that side, you're going to come to this car and then you go for C, you're going to use cos whatever angle it is all over this A adjacent over hypotenuse. Okay. Then now the last one, if you want to work with this side and this side, you go for Toa. Then you're going to use tangent theta is equal to opposite over adjacent. Then only SOHCAHTOA applies if there is a right angle triangle. I don't know if it makes sense.
Yes, sir.
Yes. So mostly with this, sometimes these questions whereby maybe they can say to you, you have 5 centimeters here, you have 4 centimeters now. What is the value of x if this angle here is 20 degrees? I doubt they can ask you that in grade 12. Now in grade 12, how they ask you this somehow, some tricky question, they will come to you and then they say, given that, given that, given, given that sine, sine angle is equal to P. Now, 1.1 is saying to you, calculate the value of cos theta. 1.2, calculate the value of tan theta, tan theta. 1.3, calculate the value of sec, sec theta. Yes. Now we are here now as a matriculant. You know your soccer tour. You are required to calculate. Do you have any idea of how we can approach this problem?
So the problem starts when like I have to know which quadrant it's in.
Sorry?
Problems. Is this one where we have to know the quadrant?
This one not necessarily. We will come to that one whereby you are required to find the quadrant, whatever, whatever. I will go to that one after we are done with this one.
Okay, so,
Yes.
so P is the the opposite.
Okay.
Then there's an invisible one
Okay.
under the
Yes.
P.
Oh, yeah, yeah, yeah. I love hearing that. So
Which
that
is
is opposite, opposite over hypotenuse. Okay, therefore we can draw your triangle anyhow. Okay, that is an angle, and the opposite is P, hypotenuse is 1. Therefore, this will be 1 minus P using Pythagoras theorem, right? P squared.
yes.
Yes. Okay, and then now 1.1.
Cos theta is equal to
So cos theta is equal to
the square root.
adjacent over a hypotenuse. Adjacent is the square root 1 minus P squared all over 1, which can be just written as 1 minus P squared. Okay, and then 1.2. This is correct. Okay, now 1.2.
It's opposite over adjacent, which is 1 over the square root of 1 minus 2 squared.
So you are saying is going to be Toa. So Toa is going to be P over the square root of 1 minus P squared. Is this what you are saying?
Oh, yes, sir.
Okay, then correct. Okay, then the last one, 1.3.
So I don't know what sec is. Which one
Oh,
sec is? For.
sorry?
I don't know what sec is.
Okay, so we have those three ratios. Let me just write some notes. Do you have a paper to write on there?
Yes, sir.
Oh, okay, you can write this. Sec, sec, theta. Then you look at the third alphabet, it's SEC, which is the normal trigonometric ratios that start with C. It's cos, but it's going to be reciprocal of that. So it's going to be cos. So sec is equal to 1 over cos theta. And then let's go for the other one, cot. Let's say cot or cotangent of theta. Then one, two, three. Third letter is T. Then usually we know our basic trigonometric ratio of T is tan. Then this is going to be reciprocal of tan. So cot is equal to tan 1 over tan theta. Tan here. And then we also have cosec. Cosec, then theta. This one is the reciprocal of 1 over of sine. Sine, I mean, sorry, not sec. Sine, sine theta. So this is what you need to know, that sec is 1 over cos theta, cot is 1 over tangent, cosec is 1 over sine theta. Does it now make sense?
Yes, sir.
Yes. So now when you talk of that sec, you are just going to say that is equal to 1 over cos theta. And then you had theta there, a cos theta on 1.1 is this. So this is going to be 1 over 1 over p squared over 1. That is over 1. Then the final answer 1 is equal to the square root 1 over square root of p, 1 minus p squared, just like this, then you are done. So even if maybe somehow they ask you to calculate cot theta, with that one you are going to calculate 1 over tan, if cosec, 1 over sine. Does it make sense?
Yes, sir.
Okay, then thank you. Now let's say, going back to what you asked me. Oh, going back to what you asked me. Mm. Let's see, let's see. Are you ready though for Friday?
Not for everything, sir.
Sorry?
Not for everything, sir.
Oh yeah, no, but I believe in you guys, eh?
Thank
Uh,
you, sir.
you guys are going to pass that paper. Are you writing paper one or paper two?
Paper one.
Paper one and paper one is not that bad, but I enjoyed paper two the most. So, with that question that you asked, now let's say you are given that. Oh man, I should not erase this. I still calculate, but now I edit some parts here. I edit some parts here. Uh, Now let me edit this one. I put negative p there, and then I now put some theta there, and then say to that theta of mine should be greater than that theta there should be greater than a 1 minus 180 degrees there, but be less than or equal to 360 degrees. Oh, no. This is going to be short. Because, yeah, now let me put 270 here. 270 here, but 90 here. Yeah, but 90 here. So how can you do this one now?
So you look at the quadrant where sign is negative.
Sorry?
I think we find the quadrant where sign is negative.
Okay, that's 100% correct. So these are our quadrants. So where is sign negative?
Quadrant quadrant three, quadrant four,
So you're saying I mean sign you're saying is negative here and where?
and quadrant three.
Okay, fine. That's 100% correct. And then,
Then we draw a diagram.
oh no. Where are we drawing our diagram?
Quadrant four,
Why for?
so that one value is positive and one value is negative.
Oh yeah. This is what I wanted to emphasize. So when you draw these things, okay, this was the correct approach. That okay, you first look at this. Okay, fine. That your sign is negative. Where? It's negative in there because this is 0, 90, 180, and then this is going to be 270. Then, okay, we said sign is negative here and here, right?
Yes,
And
sir.
then now you also use this information that theta now rotates from 90 to 270, meaning theta will move from here to there. So where there are two ticks, that's where you're going to draw your diagram.
Yes, sir.
Does it make sense now?
Yes, sir.
Okay, therefore your diagram is going to be on the third quadrant. Then our opposite is this one. Therefore, this is our P here, and then this will our one. And then now you can play around that. This is 1 minus P squared. And then this part here is going to be negative because you can see that it is on the axis that are negative here on the Cartesian plane. Can you see that?
Yes, sir.
Okay, then that's correct. Otherwise, you can now answer every question that they can ask you if you have this information. Whether they ask you cot, they ask you tan, I mean, whatever you can ask. So now, do you still remember what did I say cot theta is equal to?
1/10 theta.
1 over?
10 theta.
Oh, yes. And then cosec?
1/sin theta.
Okay. Oh, yeah, yeah, yeah. I think, yeah, you need to know that. Then now what can I also emphasize? Okay. These are what you need to know. These things that sine theta uh, over cos theta, that now this is equal to tan theta. You need to know this information just like for things like proofs, because somehow you will need to change that tan into sine over cos. Okay, and then what else can I also emphasize? So some when it comes to proofs, sometimes because they can give you something like, let's say maybe they give you something, some equation with left hand side and right hand side in trigonometry. You are required to prove something like this. So with these proofs in trigonometry, what you need to do, you need to first look on the complicated side, and then that complicated side is the one that you are going to work out until is the same as the one that is on the right hand side. But sometimes you can work out the left hand side, and then it's not going to be the same as the right hand side. Then with some cases you will have to solve both right hand side and the left hand side until they give you something that is the same. Does it make sense?
Yes, sir.
Okay. And then now what else? Now let's go to general, I think general solutions. Maybe general solutions. General solutions. General solution. So with general solutions, what do you need to know? What you need to know, because you are solving for the values of x there, whereby maybe you are given something like let's say maybe let's say you want, just like you are given something like sin x is equal to cos x, and then you are required to solve for the value of x, whereby, okay, you can do this, you can do this, okay, and then this is going to give you tan x is equal to 1, and then you solve for the value of x. So with these general solutions, what I will encourage you to do, the first technique that you can do is to look for the common factor in your general solution. Look out for the common factor. Look out for the for the co common factor. For example, because maybe with some of the things you can have something like cos squared theta, maybe minus cos theta is equal to 0. So with this thing, you can see that yes, there is a common factor. Therefore, it can help you to just factor out cos x, I mean cos theta. Then now, so that you are left with cos theta minus 1 is equal to 0. And then now with this, you are going to have two equations. You are going to have cos theta is equal to 0, or you're also going to have cos theta minus 1 is equal to 0. Okay? If there is no common factor, then just number, that is our, this is number 2. Check if you don't have a quadratic format. Quadratic format. Because sometimes you can have something like cos squared x plus 4 cos x plus 4 is equal to 0, whereby maybe you can just factorize this into cos x plus 2 cos x plus 2, and then you wave this out. And then if there is no this quadratic format, what else can we check for? Oh, check the identity. Check the identity. Check the identity. Check the identity, because sometimes you can see that you're having cos squared x is equal to 0. Then you can write that cos squared x as something like 1 minus sine squared x. Try to make something that will help you out so that you find the values of x. These are the three options that you need to look for when you're working out the general solution. Does it make sense?
Yes, sir.
Are you sure?
Yes, sir.
Okay, then thank you. So, any question regarding what we did? Do you have some specific question that you wanted to ask regarding uh this trigonometry or maybe Euclidean geometry?
So general solution was the problem, but now I understand.
Are you sure?
Yes, sir.
Okay, okay. Then what else can I maybe go look for in trigonometry? Uh, boom, 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 boom. That you can say maybe it's challenging. Mhm, mhm, mhm. Oh, this one is that one whereby you just have to simplify. So with this one, is just playing around your identities and your algebra to solve this thing. You just know that this sine 2 theta, you can just transform that to 2 sine theta cos theta. Then from there, you work out around your algebra until you get to the final answer. I think that is not a big deal. You can do that. Uh, Okay. I love this question. Okay. Can you see this question here? This one.
Yes, sir.
They say you need to calculate that question without a calculator. How do you think you can simplify that question?
There's not a special angle.
Sorry?
It's not a special angle.
Yes, it's not a special angle, but how can you now simplify that?
So I don't know if it's the one for
Sorry?
the one where we say sine 15.
Ah, yeah, 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 surprise. Hey, okay. Yeah. Okay, yes, yes, you can talk. I just never mind whatever I just said. I wanted to hide those answers. Yes.
The the one where they give us maybe sine 15 plus x in a bracket. I don't know if
I
it's related to that.
I I didn't hear you well. You were saying?
It's those questions where they ask us sine 15 plus x. I don't know if it's related to that.
Oh, no, 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 it's not. But with this one, you just need to know how to play around your identities. Can you see this identity here?
Yes, sir.
Aha, exactly. That's the identity that you're going to use here. So this is going to be equal to sine 2 times 15. then that is going to give us sine 30 degrees. Then now you can go to play around your that you're playing. 4 3 2 1 0, 4 3 2 1 0, square root, 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 and then this is going to be 30, this is 45, this is 60, this is 90 here. So sine 30, okay, is going to be 1 over 2. Is it correct? No? Sine 30. Oh, yeah, correct. So sine 30, you get 1 over 2. Does it make sense now?
Yes, sir.
Okay, yeah. So now I wanted us, okay, if this makes sense, now I want us to look at this one. Now, how do you think we can approach this one, number B here? This one, this one. Hey, it's a nice question, hey?
Yes, sir.
Yes.
So if we multiply by 2,
You are saying we should multiply by 2. You are saying here.
yes, sir.
Uh, okay, and then
Then we get the sine 2 times 22.5.
or you are saying sine 2 times 22.5. Okay, this gives us sine.
45.
Okay, sine 45. So sine 45 is root 2 over 2. So root 2 over 2. So, okay, now do me a favor. This is what we got. Please punch this on your calculator. This on your calculator and see what you get there.
It's not the same, sir.
Yes, you see, it's not the same because of that two that you introduced there. Because of that two that you introduced. So, in order for you not to ruin anything, uh, do you agree if I say to you this thing here? We have A here, we have A, and then now I multiply by 1 here. I will still get A, right?
Yes, sir.
Then now I can write this one like this. This is still 1, 2 over 2.
Yes,
I,
sir.
did, I didn't ruin anything. This is what you were supposed to do here. 2 over 2. Yes. Now, this is going to give you 2 sine whatever angle it is to 2.5 cos whatever angle it is to 2.5, then everything over 2. Then your numerator now, that's the one that is going to be now sine 2 times 2.5 all over 2. Then cos 45 over 2. What we are getting, we get root 2 over 2 divided by 2. Then your final answer is going to be root 2 over 4. Then you are done.
Yes, sir.
Are you, does it make sense?
Yes, sir.
Are you sure?
Yes, sir.
Oh, then yeah, if it makes sense, then yeah, this is where we'll end here for today. Otherwise, good luck, hey, next week with your paper one of maths.
Thank you, sir.
Cheers, enjoy the rest of your Sunday. I will see you tonight on the maths class.